Okay, so it's 12:50 and it's time to start the session on Graywater, a framework for fast scroll performance by Alex. Thank you, Eric.
Cool. Awesome. All right. Adjust whatever technical things we want to adjust. Cool. So I'm Eric Leong. So this talk is on Graywater, a RecyclerView framework that we wrote at Tumblr. I'm Eric, like I said, and I don't know, I'm from New York. I don't know what random bits of information you want to know, but cool. Let's get started on what is Graywater, why am I giving a talk on it, why do we even write this thing? Cool, Graywater is a list adapter that facilitates the decomposition of complex and varied list items for faster scroll performance. What does that mean? I'm not really sure, but basically the goal of this talk is to talk about what Graywater tries to do and how it does it. And if any of you have used Litho, this description of the library is kind of similar to Litho's, which maybe you'll find that interesting. But anyway, let's move on. So what is the goal of Graywater? Why did we write a framework on top of RecyclerView when RecyclerView already does quite a bit of stuff for us? Well, at Tumblr, we have this thing called the dashboard. Dashboard is like, I don't know, kind of like the news feed on Facebook or like your timeline on Twitter, where you see a bunch of these posts in an infinite scroll. And over the years, I think, and I started working at Tumblr 4.5 years ago. It wasn't slow. We didn't support that many features. We didn't support that many post types. But now, after 4 years of adding new features, the dashboard has gotten really slow. So the goal of Graywater is to make the dashboard fast again. But before we go and write a library, we have to figure out, what are we know what we want to do. We want to make it fast, but we're not trying to, build something that supports everything under the sun. We're trying. So what are the constraints that we had? We had infinite scroll, like I was talking about, just like any other social network. But also, we have these things called reblogs. You can see here in this post, Cheeseboard there has said, now this is a good cheese. And everything underneath is kind of is called a reblog. They're kind of like comments on Tumblr if you don't know what reblogs are. But we can have an infinite number of these attached to a single post. So you can see here that this post is longer than your screen is tall. Like I don't know, maybe Samsung will come out with a 100:9 aspect ratio phone, but for now, I don't think any screen can actually display this entire post on the screen at one time. Also importantly is that we don't have nested elements on Tumblr. Basically, in Twitter, you can quote a tweet. So this causes a tweet to be inside a little box. So you have a tweet inside your tweet. And Facebook, they also have a similar feature. It says something like, oh, your friend liked this post. So you have a post that's inside a post. We don't have anything like that on Tumblr. And that helps us a lot in terms of writing a framework, because now this is something we don't have to think about. We don't have to account for that for a feature like that. So this will guide the design of Graywater. So beyond just making it fast, so like what does fast really mean? Well, fast for us meant less jank, and jank maybe Chet is talking about this right now, or Main is talking about this right now. But basically, you want to render your frame in under 16.66 milliseconds or just 16 milliseconds. That way you hit 60 FPS. Otherwise, if you're not hitting 60 FPS, I don't think anyone would call your app fast or scroll performance as fast. Also important for us was to lower our memory usage. We had a lot of OOMs in the past before we wrote Graywater, and that was because these posts that you see here are really tall, which means they use up a lot of memory if the entire thing is kept in memory at once. Especially, like I said, there are infinite reblogs, so you can imagine having like 100 views on a single post, and maybe they could all be kept in memory or something. That's a pretty extreme edge case, though. But we're a social network, so we have to deal with this user-generated content problem. And lastly, we wanted a compositional architecture, an architecture that's easier for us to add to. So before we had Graywater, we had sort of a very basic RecyclerView architecture with switch case statements for the different view types. So you can imagine here that we had something, I don't know, we had something like 15 or 20 something view types, and you had these switch case statements that you had to modify. So you had to modify like 3 or 4 switch case statements if you want to add a new type. And that was like really, really unfun for our developers. Cool. And what are some alternatives? Like, obviously, we didn't have to write Graywater from scratch. We could have done, I don't know, we could have used any of these other libraries. Like Litho, like I just mentioned before, written by Facebook. Epoxy is written by Airbnb. And Groupie is originally released by Lisa from Genius. So these are all alternative RecyclerView frameworks. And in all honesty, I may recommend using something like Litho or Epoxy if you're starting a project from scratch. But this is why it's important for me to lay out the constraints up front. If your constraints are similar to ours, then I think maybe you should consider Graywater. But if your constraints are more similar to what Facebook's constraints are or Airbnb's, then maybe you should consider their libraries. And I think this is something really smart about how RecyclerView is designed. It doesn't really decide that much for you, but when you start building out whatever you need RecyclerView for, you start having to build out these different sort of frameworks depending on your constraints. Cool. And I made this timeline because I think it's important that we actually didn't have those choices. I think RecyclerView was released in something like 2014. So it took us maybe 1 or 2 years to switch from ListView, if anybody still uses that, to RecyclerView. During that time, Facebook published a post called Fast Rendering Newsfeed on Android. And a lot of this talk is going to cover that blog post, that engineering blog post. And so for about a year, we thought about, we know that the app is getting slower, so what are we going to do to make it faster? But we didn't actually do anything. We just had this blog post. And maybe a year and a half later, we started to actually start working on Graywater. And during that time when we were building it out, Groupie from Genius was released, and then Facebook wrote another blog post called Components for Android, and then Epoxy was released, open sourced. Litho was open sourced, and then finally, I don't know why we were last in this train of RecyclerView libraries to be open sourced, but we decided to open source Graywater, so you can find that online. I have a link at the end. So especially I've been coming back to Facebook a lot here because their Litho libraries they started developing it all the way back in 2015. So basically, we were trying to like almost reverse engineer that blog post. That blog post didn't have code to go with it, but I think Facebook's product is very similar to what we are doing at Tumblr. So that overlap has probably led to us like developing similar concepts, similar libraries at the same time. Cool. All right, this is enough of background, of history. I'm going to jump into a little philosophical discussion here about what we're trying to do in RecyclerView adapter. Really, at the end of the day, you're taking an item, some sort of model, some sort of post, some sort of, I don't know, so for us it's like a photo post or some sort of item, and you're trying to adapt it or map it to a set of views or one view. So something like your list of contacts, you're trying to take a contact and map it to, say, a text view. But the reason why I bring up this sort of like very vague concept is that we often think of the information moving from the item to the view, sort of like the item is pushing the information from the through the adapter to the view, and I think there's a pretty normal way to look at it. But the way that RecyclerView actually works is that it looks at the views on the screen that it needs to fill, and it's actually pulling the information from your list of items. So it actually doesn't even care, RecyclerView doesn't care if you're using a list of items to back your RecyclerView. It's actually just trying to fill the views that it has on the screen however it can. So I mean, you could do some like procedurally generated content or whatever, I don't know. To fill up the things on your screen, and this means that like this relationship between your item and your views can be very decoupled, and this is what we're going to try to do with Graywater. So here, very simply, is your normal, say, your list of contacts or a list of items, and they map directly one-to-one to your list of views that's on the screen. So this ends up looking kind of like this. I keep coming back to your list of contacts. It's very straight, direct, one-to-one mapping between your mental model of models backing your adapter and the views that you actually see on the screen. So this is fine normally, but what happens when your views are a lot larger and your models also are a lot larger, sort of, kind of like a photo post at Tumblr. Well, now these things take up more space on the screen, they take up more memory, and there's no reason why you need to keep this one-to-one mapping between items in your mental model and views that are on the screen. So often what ends up happening is that your item maps directly to a view holder, but then your view holder holds lots of views. Here we have 3 views. I kind of arbitrarily chose that, but the views on your screen now, not all of them are on the are like so you have 3 view holders here, but the top 2 views and the bottom 2 views aren't on the screen anymore. So this represents a sort of inefficiency. Like why do we hold in memory the views that are off screen? Well, we had a one-to-one mapping of items to view holders, so it's just a lot easier to just we're just going to bind and inflate the entire item, even though we're going to be wasting resources because not all of it is going to be on the screen. And this is especially bad for us at Tumblr because our posts can be so large, especially with the infinite reblogs, or I don't know if you've really used Tumblr a lot, you'll also see lots of photos in photo sets that come one after another. And this is especially rough when you're in between posts. So you need to render the post before and the post after and if you're some like crazy kind of like, I don't know, situation where like probably worst case scenario is that you have like a huge post and another huge post come after another. All of that stuff is going to be kept in memory at the same time. And that's where this one-to-one mapping starts to really break down in terms of memory usage and scroll performance, especially because you need to inflate and bind these huge views. So what we're going to try to move towards is an architecture where view holders hold a smaller number of views. That way, when you inflate and you bind, you're inflating and binding smaller parts of your, say, original items on every frame. Remember, your budget is only 16 milliseconds per frame, and it's very, very easy if you have a huge post to break that budget. So we no longer, in this diagram, we no longer have a one-to-one mapping from items to views. We have a one-to-many mapping. This item is going to map to many view holders, and each view holder could map to many views if you have some more complicated view. I just wrote view with an S, but obviously you can have a custom view, you can have whatever you want. And what is really nice about RecyclerView and this sort of architecture is now you can have RecyclerView handle the recycling of the views that are off screen. So the top two views and the bottom two views no longer need to be kept in memory. They can be put in the scrap or put in the RecyclerView pool or wherever, whatever RecyclerView wants to do. And we're no longer thinking about how that part of your view sort of memory budget is being handled. And this is where we start to differ from Litho. Litho will take individual text views and individual image views and try to recycle those. We're not going to try to subvert what RecyclerView already does, because that's a lot of work. They use a lot more code. Cool. And here I'm just going to walk through an example. So this was the post that you saw earlier that was on my dashboard. We're going to break up, instead of inflating that entire post at once, like we were doing before, which would take, I don't know, I forget how long it took in the past, but it was definitely over 16 milliseconds to inflate that image view, the text view, another image view for the actual photo, and then the post footer at the bottom. We're going to break it up into the header, the body here, which is the photo, and then the footer. And I want to come back to something I talked about earlier, which is we don't have nested elements. The fact that we can draw a horizontal line through the entire post, and it's basically slice the post into these parts horizontally, means that, like, normally when we, in the first case, we had a linear layout with these items. By being able to draw a horizontal line through our post, it means that, like, now these things can be recycled separately. If you had any sort of, like, I don't know, if you wanted a ripple that would cut through the post, you wouldn't be able to do this. And so this is that's one of the drawbacks of this approach. You can't have anything that breaks these boundaries because it relies on the fact that your footer may not exist, or like, so your header is going to be inflated first, your header is going to be bound first, and your photo or your footer may not exist. So if you have anything that breaks that boundary, then you will probably have to go and inflate the entire post at once. So this is like this important design constraint that your designers would have to know. Cool. So I had some pretty pictures there, but now we're going to go back to text because for whatever reason, text is a lot easier for me to make slides for. So let's say we have a photo post, a text post, and another photo post. The header and the photo are off screen on the top, and then the photo and the footer are also off screen on the bottom. And this means that those elements that are off screen can, yeah, like I said, be recycled. And now instead of having these large posts that are sort of wasting memory and wasting inflate and bind resources by being off screen, you can have these smaller individual components, like I said, that you had to horizontally slice to create. We can have those, or we can be rendering and creating only the things that are on the screen. Cool. But I said a lot of words about what we wanted to do. I basically gave you that Facebook's fast rendering newsfeed on Android post over the past 10 minutes. But unfortunately, I didn't tell you anything about how to actually do this. So like I was showing before, how do you do this map from, how do you map from one item to multiple view holders? Well, one approach is to have multiple view models. And this is probably something you would do with Epoxy and break up your single photo post into a header, a body, a footer model, and have separate models. And then have your RecyclerView adapter only do mappings of headers to view holders, or body, like a photo models to photo view holders, or footer models to footer view holders. One of the big benefits of this is that your adapter is pretty simple. Like it may not even know anything about what a photo post is. But the big problem is now if you have any sort of concept like deleting a post that involves removing the entire group of view models, then you're going to be in a messy situation where you have to go and find all the related view models to your original item, because you've decomposed your item into the components. So how do you like recombine them back into one component so you can delete them or re-add them or modify them somehow? Also, at the time at Tumblr, we didn't have anything. We didn't have view models. We didn't have like a header view model or a footer view model. So it was sort of difficult to build an architecture or a framework that supported this, because we just weren't even close to getting there. We had a lot of things, a lot of code. If you've done any sort of like messy coding with RecyclerView without any sort of framework, it's very easy for you to write code that touches, say your header could touch like some part of the footer somehow, because you just didn't have any sort of separation, because everything was inside one view holder originally. So the approach that we end up going with in Graywater is to do the decomposition inside the adapter. So the adapter still holds the list of items. Before, your adapter wouldn't hold the list of posts because it didn't need to know. And so theoretically, this is a more pure implementation. If you follow some MVVM model, or I don't know, maybe Flux, which is the talk I just heard, maybe it's more pure. But here we're going to hold the list of items. So if we downloaded 10 posts, we're going to hold the 10 posts in our adapter. But the adapter will do the heavy lifting of decomposing the posts into the constituent view holders. So what we're doing this decomposition with is a thing we call an item binder. So it's not really clear right now what an item binder actually is, because you don't know what a binder is. But I will show you that it will be more clear in the future when I a couple slides. But the important thing here is the decomposition is happening inside the adapter, which means that the adapter knows about the relationship between the view holders to individual items. So if you want to do some sort of deletion or addition of new items, it can be done inside the adapter, but there has to be a lot more code to handle that. So that's where I guess we're gonna talk about next, the implementation. Cool. So this decomposition of items by item binders, there's another layer in between called binders. And binders basically handle that relationship between the item to the view holder. The item binder really only serves the role of decomposition because at the end of the day, you are still just binding the item. So you have inside of RecyclerView, you have the create, the inflation phase, and the bind phase, and it doesn't really matter at that point. What's happening? Like that decomposition phase needs to happen already because the RecyclerView needs to know how many items are in the list. And so it actually doesn't even care how many items are in the list, it cares how many view holders are in the list. So the decomposition has to happen in the add phase. So this is how the breakdown of the RecyclerView sort of life cycle. We're going to do the decomposition on add. And then inside inflate, we're only going to look at we're not going to care about the item anymore because the view holder knows what views it needs to create. And this is sort of important for decomposition in terms of architecturally, because now your photo view holder can be used for different post types, or your reblog view holder can be used for different, you can share sort of view holders between different items. And that's important for using less memory. And lastly, in the bind phase, you still don't care about what your item came from. You don't care about what the item binder actually did. You just care about the item that it came from, which doesn't necessarily have to go through the item binder anymore. So let's just walk through an example because I said a lot of very confusing things very quickly. Okay, so we're going to go back to that photo post. We're going to have a photo post item, photo post item binder, not very creative naming here. And this actually is similar to the naming that we use at Tumblr because there's just so many types involved. So we've got a header, a photo, and a footer binder. And then the same thing with the view holders. A pretty straightforward one-to-one mapping. But remember that a header binder can also bind something like a text post to a header view holder. So the header binder actually has quite a bit of logic inside of it for the different post types, or you can separate it out you could have like a photo post header binder if you wanted to do some more specific type gymnastics. So, like I was saying earlier, when we add, we're going to decompose. It's kind of weird when you're adding something, you're decomposing it. When you add a photo post to the adapter, it goes through the item binder and tries to figure out, okay, we need a header binder, we need a photo binder. And in Tumblr, this is an important problem for us because a photo post can be so different. We can have like text, we can have I don't know, more than one photo, we can have multiple photos inside our photo post, so maybe there'll be 5 photo binders, and then there'll be the reblogs, like I was talking about earlier, and then we have the footer. We can have like a lot of different binders in the middle, so I'm just keeping this example simple, and in this decomposition, the item binder will do the decomposition, but it no longer really comes into play after this. Because once the decompositions happen, like we're not expecting the photo post to change. Now, if the photo post did change, then yes, you would have to go through this step again. But this step is very inefficient because you have to go and look through the photo post to see all the things that it needs. So we want to avoid doing that. But another important part of this is where does this item binder come from? Like I've thrown like tons of types at you over the past say 20 minutes or 30 minutes. And I talked about how we want to achieve a composition architecture, but like these photo post item binders and these header binders need to come from somewhere. So the best way of getting them into the adapter, instead of having the adapter create them or register them in some other frameworks do something like that, we're going to use dependency injection or some sort of map of types to binders. So here we're going to have photo post is going to be a type, and we're going to look through the map of binders that we have, and then we're going to grab the photo post item binder. And we also want to avoid creating extra binders when we don't need them. So we're also going to have a map of items to binders, and we're going to use the type of the item as a sort of key into our map. And that way, if we see a text post, we can reuse the same header binder, or we can reuse the same footer binder, and we're not creating new binders for every single type that we're encountering or every single item that we're encountering. Like we're trying to avoid memory churn by using a map of binders and item binders and reusing as many binders as we can. So the only thing that's being created here is a new list, which hopefully is not too expensive in Java. Should be a list of references to binders. Okay, that was the add phase. That's one of the most complicated phases of Graywater. I'm going to walk to inflate, which is probably the simplest phase of the RecyclerView lifecycle, which is on create when you're creating a view for a new type. So we're basically going to use the type as the view type in our RecyclerView. It's a lot easier this way. You can do kind of clever stuff to sort of generate the type numbers, but it's a lot easier. I think it's recommended in the Android documentation to just use the ID, the layout ID, as your unique view type identifier. So when we inflate, we're going to use that layout ID and just inflate it. I mean, a header view holder is not really coupled to the idea of a post or a photo post specifically. And I think this is very different from the way you may normally think about recycle views. You may intuitively think that, say you have a list of contacts. I kind of keep coming back to that example, but your contact is not necessarily one-to-one mapped to your contact view. You don't necessarily need to grab the contact model type before you inflate the contact view. So this sort of decomposition is very useful for, when you want to add a new type that's just a remix of existing views. Well, you can do that without creating an entire new switch case statement that goes through and adds a bunch of new view holders and new view types to go with new type that you just added, new item type that you just added, which just wastes a lot of time. And this is a big problem for us because if we have we go from photo post to a text post, there's no, if they both have headers, then why are we duplicating the header inflation code? Well, we had XML files that had I don't know, so I'm gonna say 30 or 40 views in them, and most of them were duplicated because our post types were mostly the same, except for the body being different. Cool. So where do these view holders come from? Well, we have these not very cleverly named view holder creators that do the inflation. And like I said, they mainly have the layout ID, which is the main bit of information that you know. But they also, the view holder creators, they're in this box because they're also a map of layout IDs to the view holder creators. And that's important because the view holder creators because they're in a map, now we can go and grab them and not create new ones every single time we encounter a new type. We can just go into this map and we can grab like the relevant one, and then inflate, and then all the viewholder creators can be created or provided on adapter initialization. All right. And lastly, bind. Sort of drawn this weird line here, where binding has to go this weird sort of a combination of different things in order to go from the item, which is the original thing that we're starting from, all the way back to the view that we're trying to display. This is where obviously you're going to take the name or the photo URL or whatever content you were trying to display and associate to the view that doesn't know anything about the original model. And that's what the binder tries to do. So inside Graywater, we maintain the association of how the decomposition happened. We know how we got from photo post to the individual binders. So now in the bind phase, we take that information that we've cached and we pass the photo post to the binder, and we pass the view holder to the binder, and then the binding can happen. I say that very simply, but the code for it is kind of crazy. I don't want to dump code on the slides. There's actually no code in this talk. But the entire library is under 1,000 lines, so kind of crazy. So I guess I could have shown code, but I don't know. It's some sort of generics nightmare. Cool, if you're into generics nightmares. So finally, the last thing I really want to get into is, I was talking about dependency injection earlier and maps. Dagger has this new feature called map multibinding, which makes this a lot easier. And it was only released like I think 6 months ago, or in July or June or something like that. And with map multibinding, we can inject these binders, item binders, and viewholder creators into an adapter with just the straight up Dagger map multibinding annotations. And this makes it really easy for us to have different behavior on different screens. And this comes back to that compositional architecture I was talking about earlier. We want, on different screens, we want different post types, we want different behaviors like text or photo, and also on different screens like our inbox versus our dashboard, which also display posts to have different behavior. So this sort of like plug-in architecture that map multibinding supports is super useful and works really well with Graywater, even though Graywater doesn't directly use Dagger. However you decide to dependency inject the maps into your Graywater adapter. Well, Dagger is the example I have in the code base in the open source repo. But however you decide to do that, it makes your life a lot easier, because having different behavior on different screens is something that's like I think common to a lot of apps, especially something like I don't know if there's a good example on Facebook. Maybe your news feed versus your wall will both display posts, and clicking on buttons on the different screens will have different behaviors. And this also has a huge upside for testability. Like, it's very tempting to create a sort of monolithic adapter that contains all the possible post types or all possible things that you could display on a screen in one place, and then testing that becomes some sort of insane I don't know, test of patience, because we basically didn't have unit tests for our screen before Graywater existed, because it just there's so many possible behaviors that were encoded into a single adapter, and being able to tease out exactly what we wanted in the test was just as hard as trying to tease out what we wanted in the first place. So the nice benefit of this sort of compositional sort of plug-in system that Dagger supports is also unit testing. And I mean, I did throw a lot of random new terms at you, but it all comes down to separating concerns, or separation of concerns. Cool, so I talked a lot. You probably just want to see the results. So the nice thing about Graywater, after all is said and done, it took us about a year to rewrite our dashboard in this new framework. And we reduced our out-of-memory crashes by 80%, something like, I don't know, I want to say like 1 kilohertz or something like that, like 1,000 crashes a second, or something like that, and down to, I don't know, a lot less than that. I don't know if it was 1,000 kilohertz or something. It was a lot. It was a lot of crashes every minute or every second. And there's a lot less jank now. I haven't actually gone through measurement of this recently, because obviously I'm not going to go back to the old code on a new device, but before it would take something like several seconds sometimes to inflate a really long post that had a lot of views, possibly even hundreds of views. And obviously it's a lot faster now because we're only inflating individual components of a post. And also, lastly, like I said, we have a lot more unit tests for associating that association between the post and what we're trying to see on the screen. Because now it's not all tied up into a single adapter. Cool. I showed a little bit of the PDF app, I guess. All right. I guess I want to finish up with why do you want to use Graywater? Well, it's simple. It's less than 1,000 lines of code. I would say I think most of it is comments, because the code itself is kind of messy because there's a lot of sort of messy type gymnastics that we had to do in order to make it work. I put no custom layouts as a why Graywater, but if you use Litho, Litho has I'm comparing a lot with Litho because Litho covers a lot of similar ground, and obviously it was based off of the same sort of ideas as Graywater. But Litho has, I think they're called component specs, and they're kind of like, they're custom views. They have a custom layout system that they use. And if you don't want to switch to that for whatever reason, like we didn't want to, because like if you want to use constraint layout, then like I don't think Litho has an equivalent. Or you can use constraint layout with Litho, but I don't think then you lose the sort of benefits of recycling text views that Litho has. So I don't know, it's sort of a conscientious design choice because at Tumblr we only have, I think we have only 15 Android engineers, and I think Facebook has maybe a few hundred. So we don't have time to write our own custom layout system. But that's cool. They invited me to give a talk on this. I'm hopefully not totally crazy. And the last thing is that it's UI thread only, also similar to Litho, or dissimilar from Litho. Litho has asynchronous layout rendering that they support because they have the custom layout solution that they wrote. But Graywater only runs on the UI thread. There is some sort of magic that RecyclerViews do around not prefetching, but yeah, actually prefetching and pre-inflating views, and they added that maybe like 4 or 5 months ago. And I'm sure Romain can talk more about it, or I forget who works on RecyclerView. But that sort of all that magic that RecyclerView does, like we're just using for free, and we don't do any sort of like crazy magic that sort of sidesteps that, because we just don't. It's not that complicated of a framework. All right, cool. That's my Twitter, and that's the repo that you can find Graywater on. So cool. Thanks for coming over the Romain's talk, but sure you can see it online. Thanks.
Thank you, Eric.